Good morning! It's October 21st, and this is your daily brief in science. Here's everything you need to know. A new breakthrough in vision restoration has emerged with a clinical trial demonstrating the potential of a tiny wireless implant called Prima, combined with augmented reality glasses, to help some patients with advanced, dry, age-related macular degeneration regain reading ability. The Prima device is a subretinal photovoltaic implant placed beneath the retina, which activates about a month after surgery to convert visual scenes captured by glasses into electrical signals sent to the brain. This allows patients to perceive shapes and patterns, aiding in vision. Patients undergo extensive training to interpret these signals, and the procedure itself is minimally invasive, taking less than 2 hours and performed by trained surgeons. No significant decline in peripheral vision has been observed following implantation. Developed by Stanford professor Daniel Palanker and manufactured by Science Corporation, the device is not yet fully approved in the US or Europe, but aims to be affordable and accessible, with regulatory approval underway. Experts describe this as a paradigm shift in artificial vision, with hopes it could become available on the NHS and transform treatment options for AMD patients. However, the Macular Society notes that the implant is not suitable for individuals born blind due to lack of a functioning optic nerve, but it offers hope for those with progressive retinal degeneration. Future plans include increasing the device's resolution, which could improve visual acuity to near 20/20 and enhance features like face recognition and zoom. Ongoing development aims to expand its application to other types of blindness caused by photoreceptor loss, with improvements in resolution and aesthetics. Currently, vision improvements are limited to black and white, but researchers plan to add grayscale and color functionalities in future versions. The system requires months of training for effective use, including adjustments for zoom, contrast, and brightness, with users reporting high satisfaction and daily use for activities like reading and navigation. Despite some minor surgical events, the safety profile remains acceptable, and Science Corporation is seeking regulatory approval to bring the device to market in Europe and the US. The company, led by former Neuralink co-founder Max Hodak, acquired the implant from bankrupt French startup Pixium Vision and is working on refining it into sleeker, more portable versions. This successful trial marks a significant step toward providing new hope for individuals with untreatable retinal degenerative conditions and represents a major advancement in vision restoration technology. Breastfeeding may offer long-term protection against breast cancer by boosting immune defenses in women. A study published in Nature on October 20, 2025, found that breastfeeding increases specialized immune cells called CD8-positive T cells in breast tissue, which can help prevent tumor development. Data from over 1,000 breast cancer samples show that women who have given birth tend to have higher T cell infiltration in their tumors and better outcomes, especially in triple-negative breast cancer. Mouse experiments confirmed that breastfeeding reduces tumor growth and enhances T cell presence within tumors. Removing these T cells eliminated the protective effect. The research highlights the role of the involution phase after breastfeeding, which creates an environment rich in inflammatory signals that promote immune memory. The study emphasizes that longer breastfeeding durations might strengthen immunity, possibly through prolonged microbial exposure via the infant's saliva. However, determining the optimal breastfeeding length remains challenging due to reliance on observational data. The findings also point to societal issues, as low exclusive breastfeeding rates in Australia, at only 16% at 6 months, limit potential health benefits and call for better community and workplace support for mothers. Researchers note that women who do not breastfeed despite having children, particularly African American women, face a higher risk of triple-negative breast cancer. While not all women can or want to breastfeed, understanding the biological pathways involved could lead to interventions that mimic the immune protection provided by breastfeeding. A new study demonstrates how digital tools can significantly improve early detection of lung cancer by directly reaching high-risk populations. Traditional barriers, such as lack of awareness and limited time during primary care visits, often prevent timely screening. Researchers from Wake Forest University and UNC conducted a large randomized clinical trial involving over 26,000 smokers to evaluate the effectiveness of the digital health platform Empath-Lung. The platform offers education, decision aids, and appointment requests outside of traditional clinical settings. In the trial, 1,333 eligible smokers used Empath-Lung, resulting in a rise in screening rates to 24.5% within 16 weeks, compared to 17% in the control group. The study reported no adverse events or complications from the screenings, indicating the safety of combining digital outreach with standard procedures. Results showed improved screening rates across all demographic groups, suggesting digital outreach can reduce disparities. Experts note that methods like electronic health record portals and text messaging are scalable and can complement primary care efforts effectively. Building on these findings, the team launched Empath Health, a startup aimed at expanding access to these digital tools nationwide. The broader potential includes adapting similar solutions to other screening programs, especially in underserved populations. Lung cancer remains the leading cause of cancer-related death in the U.S., with less than 20% of eligible Americans screened annually due to barriers like awareness and time. The Empath-Lung program includes educational videos, decision aids, and screening appointment requests, all accessible outside clinical visits. A published trial in JAMA confirmed that digital interventions increased lung cancer screening completion from 17% to 25% among high-risk individuals within 16 weeks. A new study sheds light on the limits of human endurance by examining the maximum sustainable metabolic rate, or metabolic ceiling, in ultra-endurance athletes. Researchers tracked 14 athletes, including ultra-runners, cyclists, and triathletes, over periods ranging from 30 to 52 weeks. They used doubly labeled water to measure real-time energy expenditure during their training and competitions. The findings indicated that even the most extreme athletes could not exceed an average metabolic rate of about 2.5 times their basal metabolic rate. This aligns with previous theoretical predictions about human energy limits. While some individuals may temporarily push beyond this ceiling, most are unlikely to sustain efforts above it without risking injury or health issues. The body's ability to absorb and process nutrients constrains this metabolic capacity, making long-term excess efforts biologically unviable. During prolonged activities, athletes naturally adopt energy conservation strategies such as reducing non-essential movements and resting more. The study's athletes, mostly ultramarathoners who covered an average of over 6,500 kilometers, provided valuable insights into the physical boundaries of human performance. These results have broader implications for understanding energy allocation in human biology, including effects on immune function, aging, and reproduction. Despite limitations like small sample size and reliance on models, the study highlights the importance of biological constraints in extreme endurance efforts. The Millennium Seed Bank at the Royal Botanic Gardens, Kew in England is celebrating 25 years since its opening in 2000. It now holds over 2.5 billion seeds from approximately 40,000 plant species, stored in a secure, climate-controlled vault. Seeds are collected from around the world, including locations like Madagascar, Thailand, Greece, and Arctic Sweden. These seeds undergo a process of drying, cleaning, viability testing, and are then stored if alive, with precise control of temperature and humidity. Manual cleaning and germination tests ensure seed viability before sealing in glass jars or foil packets and storing at -20 degrees Celsius. Nearly half of flowering plants face the risk of extinction, making seed preservation critical for biodiversity. The bank's goal extends beyond storage, aiming to support ecosystem restoration and combat biodiversity loss by serving as a genetic insurance policy. Future efforts include developing cryopreservation techniques, such as liquid nitrogen storage, to preserve tropical seeds with high water content that cannot survive freezing. Experts highlight that seed banks are essential for maintaining genetic diversity, which enhances resilience against threats like climate change, disease, and habitat loss. The collection of 40,000 plant species represents vital genetic resources that could aid in restoring ecosystems and recovering endangered species. Seeds are stored in a way that doubles their lifespan with every 1% reduction in moisture and every 5 degrees Celsius decrease in temperature. Built to withstand disasters, the seed bank safeguards Earth's plant diversity, supporting global conservation efforts. Over 3,000 scientists from 70 countries have been trained in seed collection and storage, and Kew has launched a £30 million Seeds Future Fund to expand research and partnerships. This has been your Daily Brief in Science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.